Okay, this is part 4 of lesson 8.6. So now let's estimate some probabilities using normal distributions. So again, we're going to stick with the penny example. It says the masses in grams of pennies minted since 1982 has an average of 2.5 grams, standard deviation of only 0.02. So now we want to estimate the probability that a randomly chosen penny has a mass greater than 2.52. So we want to find the percent of pennies that will actually have a mass that's greater than this number. So again, I'm going to draw our normal distribution as best I can. And again, we're going to put the mean right in the middle. And then just want to make sure that you guys understand these percentages. So the first standard deviation is 68%, which means each of these areas represents 34% of that space. And then as we go out one more standard deviation, we're looking at 13.5% on each side. Okay. And so that's out 2 standard deviations. And now if we go out a third standard deviation, now we're looking at 2.35%. So 2.35%, 2.35. And then, we get down to this little tail area and we're looking at only 0.15% of the population of whatever it is that we are examining. So for this one, we want to know ones that are greater than 2.52. So we take 2.52, we subtract our mean, 2.5, and obviously we get 0.02, which is, 1 standard deviation. So that means we are looking at all pennies that are more than 1 standard deviation away. So that means we are not including this 34% because that is 1 standard deviation. Instead, we're looking at the rest of this area. So we're looking at all of the values that fall right here. Okay? Very, very simple. So now all we have to do is take those percentage amounts and add them together. And that's the probability of a penny actually weighing more than 2.52 grams. So that means we're taking 13.5% plus 2.35% plus 0.15%, and we get roughly 16%. So only 16% of all the pennies that are minted are ever going to be greater than this number. All right, let's try part B. It says estimate the probability that a randomly chose penny has a mass greater than 2.56. So once again, 2.56 minus our mean, 2.5. That gives us 0.06. That's 3 standard deviations away from the mean. It's pretty unlikely that anything is going to fall 3 standard deviations away from the mean, but the chance still exists. So let's look at that chance. When we go back up here and look again, this is 1 standard deviation away, 2 standard deviations away, 3 standard deviations, and we are looking for anything greater than 3 standard. So it can only be things that fall in this range. So the probability is 0.15%. So there is a less than 1% chance that you're going to come across a penny that weighs more than 2.56 grams. It's going to be very, very rare. To put this in perspective, since it's less than 1%, that means not even 1 in 100 pennies is going to be at this amount. In fact, not even 1 in 100. It's only going to be about 1.5 in every 1,000, or 15 in every 10,000 pennies are going to actually be greater than that. All right. So now I want you to try these next two problems on your own. So pause the video for a moment. Okay, now that you've come back and you've unpaused this, let's see. Let's find the probability that a randomly chosen penny has a mass less than 2.54 grams. So once again, I'm going to take 2.54 minus the mean equals 0.04. Okay, so that's 2 standard deviations above what we're looking for. So if we go back to our model, so again, we're looking at not 1, but 2 standard deviations above. And so we're looking for anything that is actually below that amount. So that means we're going to be looking at this area, this, so all of these areas that are below. The only thing that doesn't count are things that are 3 or more standard deviations above. So then when we go back to our percentages, we know we're going to have 13.5%, okay, plus both of the 34% areas, including the one that's below, and then the other 13.5% that's below, the 2.35%, and the 0.15%. And what we get is 97.5%. So 97.5% of all the pennies that you find are going to have a mass less than 2.54. All right, D. Let's find the probability that a randomly chosen penny has a mass greater than 2.44. So again, we take our mean minus this quantity since it's smaller, and that gives us 0.06. So this is 3 standard deviations below. And again, we want to know how many what's the probability of a penny having a mass greater than this? Well, the probability is pretty high that a penny is going to be greater than that, because we are now looking at anything that's more than 3 standard deviations above, including 3. So if we go back to here, that means we're including, this is out to 3 standard deviations. That means we're including all of this. So there's 2 ways we can do this. One, we can just add all these percentages together. The other thing we could do is, remember, all of this is 100%. So if we want, this is another way to look at this, we can take 100% and we can subtract the area that's not going to be included. And in this case, that's this one little area out here, 0.15%. So I subtract 0.15%. and I get 99.85%. So there is a 99.85% chance that any penny chosen will have a mass that's greater than 2.44. Okay? And that's how we can use normal distributions. As long as we know the mean and standard deviation of a population, we can use the rules of a a normal distribution to actually make predictions as to what the chances are of getting a certain result if you were to just take a random sample from a population.